All right, I'm getting better about remembering that. Okay, so last time we were working on this notional organization that was making an investment in a piece of equipment that cost them $240,000. We had this information about them. So this is, I'm trying to kind of teach you a couple of things at the same time. So one is, I'm trying to teach you how to build a good Excel model. Right, so this is more than just a spreadsheet, right? This is actually a model of how that will allow you to manipulate your assumptions, and we'll do that in chapter 15. We will look at some impacts of modeling sensitivity analysis and scenario analysis. And so if we build something like this, it becomes really easy to do different both scenarios and sensitivities. So we have the NPV over here, right? So under the assumptions that we have, because this is all interconnected, I could make a change in the assumption over here. Let's say I decide, you know what if we do 10% more volume? I could plug in 5,500 instead of 5,000. Right, that goes ahead and changes my revenues. It changes my supply costs. It changes my operating income, my net operating income. It then changes my net cash flows. Right, it changes my payback period. Right, from we had 2.43 to 2.03. But more importantly, if I jump to the NPV, you know, all of the cash flows carried over here with the programming we had in place, and we can see the NPV is 172 as opposed to whatever it was before. Let's see, I don't remember. 5,000, I can change it right back. 5,000, it goes to 103. So when it jumps 107, it jumps by 70,000 by a increase of 10% in my volume assumption generates an increase of about 70% in my NPV. So NPV is very sensitive to a change in volume. And if we dropped by 5%, 10%, let's say, and we did 4,500, right? Also very sensitive. So now it goes, our payback, we'd have to do another year because it doesn't fully pay back. Our NPV falls from 103,000 to 34,000. So that's an example of sensitivity analysis. We'll talk about that a little later. I'm just kind of demoing that. So when you build an Excel spreadsheet, you want to build it in such a way that if you have kind of core assumptions like volume or net revenue, you kind of build that, and then you reference the assumptions inside the model, so that then you can quickly change your assumptions and it feeds the model, right? So I changed my supply assumptions 40 to 50. So that's that is an important skill that you're going to want to develop going forward. All right. So then we worked on NPV. We said our corporate cost of capital is 10%. We pulled in the cash flows and we kind of transposed them into a column as opposed to a row, right? But we pulled them from here, right? And then we said, okay, if we're going to kind of manually muscle through this, we can calculate the present value of each of the cash flows individually using our present value formula, right? Which is the cash flow divided by 1 plus the cost of capital raised to the number of years that it's being discounted back, right? Because this is NPV, we're discounting back. So we did that for each year individually. So, for example, we discounted 95,000 one year to bring it back from 1 to 0. We discounted the second year cash flow for 2 years, bringing it back to 0, right, and so forth. And then we sum up each of those present values and get a total present value of the investment. Subtract off the original cost of the investment. And we get our net present value. So these are things we've done in the past. doing it in Excel instead. Now you could have done this with your cash flow function on your calculator as well, but given our circumstances have changed, it makes sense to start working in Excel and learning how to do Excel. Now, afterwards, after we kind of went through the more manual process, if you will, I showed you there is in fact a formula to calculate the present value of a series of cash flows. And for some reason they call it NPV, and I object to them calling it NPV because there's no net here, right? It's not a net present value. This is simply the present value of an annuity. So it should be called something like PVA instead of, present value of an annuity rather than net present value, because net implies something is being subtracted. And whenever you talk in any other circumstance, when you talk about NPV, you're talking about the present value of the cash flows minus the investment. So I don't know why Excel does that. Obviously, somebody with a marketing degree and not a finance degree developed that one. But you can use, there's a lot of these kinds of functions in Excel that are really marvelous and really easy to use once you get used to how Excel works. And so, I kind of go back and forth as to whether I use the NPV function or whether I program in the individual assumptions. Sometimes I like to see the inner workings of the machine. And so, in fact, a lot of times I like to see the inner workings of the machine. And so a lot of times I will take the extra step to calculate that in. But this will work, right? So if I give you on the exam, when I ask you a question about chapter 14 and I say, give me the net present value of the cash flows from a particular project, you can just do NPV to get the present value of the future cash flows. Just remember, it's not, even though the formula is called NPV, it's not actually NPV. You still have to subtract off the investment value to get the actual NPV. So, when you take the exam for chapter 14, I'm going to give you a problem to solve in Excel. I see somebody's trying to chat me, but I'm having trouble with okay. Could you go over cash flow and PV from year 4? Everything else I have is right, but mine are off for year 4. Okay. Let me make sure I didn't make a mistake. So you're getting the same cash flow as mine for yours is also different for year 4. Okay, lots of people have different fields, so let's back off for a second. What do you have for a cash flow for year 4? Is it 140 or no? 134. Okay. So we go back to this. So to figure that out, we need to go back to the sheet. So let's go back a sheet here. So do you have on the original sheet? Does your sheet agree with me here? So it must not, because you don't have. Okay. So where do you deviate? You need to. So is it
where the net operating income for what you have for number 4 is what we have. Wait, hang on. You have an extra here.
Oh, hey, I have an extra column because I was working on it. All right. Yeah, I was working on something before you guys. Okay. That's why we don't agree. Hold on. 1 second. Let me just check this. Yeah, all right. I was working on something that I wanted to show you. Should be able to. That's why you're different. Thank you. All right, now we're back. You said 134,974. Yeah, that's right. And we're back there. Okay. Yeah, I was messing around before class and I forgot to clear it. Okay. Okay, thank you for pointing that out. I forgot I had made that change and didn't change it back. So we have net present value. Is everybody in agreement with me now? Or is there still an issue?
It's good for me now.
Okay, thank you for pointing it out. Okay, so we take the total here of the present value. That gives us the present value of the cash flows, right? Then we subtract the investment. Then we did the internal rate of returns, a little more tricky. What the internal rate of return asks is, what interest rate would we have to use in order to, generate a zero NPV? So let me, just to refresh the theory behind this, I'm going to switch my view. Okay, so this is always a pain. Can never quite get it so that the image is not distorted. Okay, so remember, we have, so in this particular problem, we have the 4-year cash flow. So 0, 1, 2, 3, 4, but it doesn't matter that it's 0, that it's 4 years. We have and I'm going to round these just to save my writing. We have an initial outflow of 240. Then we have roughly 95, 100, I'm rounding up, 105, and 135 cash flows, right? And these are roughly, these are very roughly rounded. Those are our cash flows. And so with NPV, what we do is we say, okay, I'm going to bring this 95, and my CCC is 10%. So I'm going to bring that 95 back to the present by dividing it by 1.1 to the first power. And that brings me back, it brings this 95 back to what it's worth at time 0. Then I'm going to bring this one back, right? And it's going to be 100 divided by 1.1 squared. Then I'm going to bring this one back, and it's going to be 105 divided by 1.1 to the third. And then I'm going to bring this one back, and it's going to be 135 divided by 1.1 to the fourth. And if you use the NPV function, or you use your cash flow calculator to do this, that's what this is, that's what the calculator is doing, or that's what Excel is doing. So then we add these results all up. So that's 70, roughly 75, 62, 51, and oh shoot, I'm using wrong. Going back to the NPV, 86, 82, 79, and 92 roughly, and that adds up to 339, 682, right? So what we did was we transported these future cash flows to the present and we used the discount, the cost of capital of 10% as the discount rate. And then we compared the present value of these future cash flows to the outflow at time 0. So we get 339-ish minus 240 gives us roughly, the more precise answer, 99,682 is what we came up with. And I realize that's a rounding. So that's how NPV works, right? But then we took the same idea, and here with NPV, we're working with our corporate cost of capital and trying to test to see whether the investment yields more than 10%. And if it yields more than 10%, then we have an NPV greater than 0. If we do the same thing with IRR, now we're saying, okay, I'm going to bring this back, 0, 1, 2, 3, 4. And I'm going to say my IRR is equal to some unknown I. I don't know what that is. So I'm going to bring 95 back, and I'll say, okay, it's 95 divided by 1 plus I to the 1. I'm going to bring this 100 back, and it's going to be 100 divided by 1 plus I squared. I'm going to bring this 105 back, and it's going to be 105 divided by 1 plus I cubed. And then finally, I'm going to bring this 135 back, divided by 1 plus I to the 4th power. And I'm going to add all that up, right? I'm going to add all these up. And my goal is that I want to set I, right, this unknown interest rate, I want to set I such that when I add all these things up, it adds up to 240,000. So when I add up all these present values, right, it adds up to 240,000, so that when I add my 240,000 to my negative 240,000 initial cash outlay, I wind up with an NPV of 0. The IRR is the interest rate that I would plug into each of these formulas. Okay, so I'm trying to kind of rehash for a minute the theory behind what the IRR actually was, because this one is a little tricky. So when we did that calculation, right, let's put, let me go back to my sharing my screen again. So when we did that calculation, we started off with the assumption that our IRR was equal to our corporate cost of capital. But we programmed in, when we did it manually, we programmed in and we said, all right, it's going to be the cash flow, 95,000. That's what's in the hold on. Stop. We programmed in, right? The numerator is D5 is our cash flow divided by 1 plus the IRR, the interest rate that we're going to use for IRR. And we didn't know what it was, so we're just putting a placeholder of 10% in there, raised to C5. C5 is the number of years that this cash flow is going to be carried back in order to get it to 0, right? So we plugged in, just like we did for the PV, for the NPV, the corporate cost of capital. But what we want to do now is do what I just was drawing on, right down here, what I was just drawing. I want to set this interest rate so that this 339 becomes 240. So what I did was I went up to data, right? And then I went to this what if analysis, which I think is a really cool tool. And it only works if you build your spreadsheet in this relational way, right, where everything is connected. So we say, okay, goal seek, I want to set this cell, the present value of the cash flows, to 240,000, one more 0, by manipulating the interest rate right here that we put in here in the denominator for each of these. So we just say, okay, go ahead and do that for me. And it goes ahead and does that. And it says the interest rate that you have to put in here for D1 is 27% in order to make the present value of these cash flows reduce down to 240,000. So in other words, we're not getting a 10% return on our investment. We're actually getting a 27% return on our investment. And then I said, okay, you know what? Again, Excel's got these great formulas in here, so I can just, and one of them being the IRR formula. So I can just say equals IRR, right? Open parentheses, And in this case, I'm going to take in both the investment as well as the future cash flows. You don't have to put a guess in. I don't even know why that's really there. And then it'll give you the 27%. So if you have a problem on your exam, right, that requires you to calculate an IRR, as long as you have the cash flows set up properly, right, as long as you've got this column set up properly, you can run an IRR just by, you know, using that IRR formula. So it's pretty cool. Now, one of the things that's implied about, so that's kind of, that brings us up to where we were last time. So one of the things that, so the last thing I want to teach you about is the MIRR, or modified internal rate of return. So the modified internal rate of return works a little bit differently than the IRR. Oh, let me switch views again. One of the assumptions that's built into the IRR calculation is, and it's hard to kind of conceptualize, but one of the, so as it turns out, in this case, our IRR is 27%. Now, 27% is a pretty amazing return. It's the kind of return that you know, pharmaceutical companies see on, you know, blockbuster drugs, or really high performing drugs, maybe not blockbuster, but high performing drugs that they produce, right? 27% is a really high return for any firm. What's implied in this calculation is that when I earn that $95,000 at the end of the year, I'm going to be able to reinvest that that $95,000 at 27% when I earn that $95,000, and then I'm going to be able to, when I earn the $100,000, I'm going to be able to reinvest it at 27%. And when I earn the $105,000, I'm going to also be able to reinvest that at 27%, and so on, which is probably an unrealistic assumption. Because this is such a high rate of return, and the firm's corporate cost of capital is only 10%, right? So, so this 27% return represents a pretty exceptional project. The average project for the firm ought to be something around 10%, you know, give or take, as a result of maybe some successes and failures. But just on average, a more realistic expectation is that when I earn that $95,000, right, the firm gets that cash in. Well, what do they do with it? Well, they're gonna, you know, they'll either pay it out as a dividend, or they're going to reinvest it in another project that the firm is going to take on. Most of the firm's projects are not going to yield 27%. They're more likely going to yield something like 10%. So the modified internal rate of return takes that into account. So the modified internal rate of return is something closer to reality. Now, this is the process of calculating the modified internal rate of return is a little more complicated than these other two that we're doing. So I'm going to go ahead and copy. So if you're following along now, I want you to go ahead and click on the IRR sheet down at the bottom here on the sheet name. Right click so that you get this window pops up with these choices. Again, choose, and we did this before, but choose move or copy. And then when this box comes up, choose create a copy and move to end. And what you'll have is IRR2. Is anybody stuck on that? Everybody able to do that? Let me say, if you're not able to do that, can you chat me and I will do it again? So I'll talk it through one more time. So if you haven't done it already, you click on the IRR, right click, choose move or copy, select create copy, tell it to move to the end, though that's not super important, and then you hit OK. I'm not going to do that because it'll make another sheet, which is not a big deal because you can just delete it. All right, I'm going to rename this sheet, and the way I do that is I just double click on the sheet with my left mouse click, double click. I'm going to call it MIR. I'm going to change this, rename this MIRR, and rename this MIRR. And I'm going to just delete this column. Okay, so go with me now. So I've renamed these. I'm going to just delete this column, delete the whole thing because I'm going to rename it. Okay, and let's switch views for a second. Sorry. Okay, Matt, I didn't see the chat. Are you good, Maddie, or need? I'll do it one more time. Okay, so I'm back here. I'm going to be on IRR. I'm going to right click on IRR. I'm going to choose move or copy. I'm going to choose create copy. And then I'm going to choose move to the end. Though that's really not that important. More important to make sure you choose create copy. Then I'm going to hit OK. Right, now that's created an IRR2 sheet. So you should have an additional sheet here. I'm going to delete that because I don't need it, because I've already done it. So anybody need to see that again? Okay, all set. Good. Sorry, the chat box is a little finicky. It kind of disappears when I'm not. Okay, so I'm going to switch my views now. All right, and so here, right, with the IRR, we were looking for the interest rate that would bring all these investments back, but the implication of that at some interest rate, but the implication of that is actually that these things will go into the future also at that 27%. So things are going to move back and forth in order to back and forth at this IRR, this very high IRR. What MIRR looks like, before we do it on the computer, right? So we have our setup again: 240, 95, 100, 105, and 135. Right. So what what MIRR does is it says, you know what, we're interested in, we want to know the interest rate. We're still going to do the same idea. We're going to try to get to a interest rate that gives us an NPV of 0, right? So that means that we want to somehow arrive at a present value of the future cash flows that's $240,000. But the way we're going to do that is we're not going to assume, right? So we're going to assume, instead of assuming that we're going to be able to get this project's reinvestment rate, so we're going to focus on a reinvestment rate. Instead of assuming that we're going to be able to do an identical project, basically, so when we get this 95,000, we'll be able to what the IRR implies is we'll be able to take that 95,000 and push it into a project that's identical to this project. Since that's not a realistic expectation, but instead we ought to be thinking about something, a rate that is something probably more like our corporate cost of capital. A more realistic, we want to come up with a more realistic reinvestment rate. Now, I'm saying corporate cost of capital. The MIRR does not require that you use the corporate cost of capital as the reinvestment rate. It just requires that you decide on a reinvestment rate that would more accurately represent, if this project spun out $95,000, what would you do with it? Well, you're probably not going to be able to do an identical project. You might, so you'll have to reinvest it in something else that this company does. So that's why I tend to revert to, well, then we ought to use the corporate cost of capital as kind of our baseline. What we're going to do, to capture this idea of reinvestment, is instead of taking these cash flows back to the present, we're going to take them forward into the future. Okay, so we're going to calculate the future value of each of these cash flows using whatever our reinvestment rate is going to be. So for this exercise, I'm going to make the reinvestment rate equal the corporate cost of capital. But you, as an analyst, get to pick that. So you could pick 10%, or you could say, you know what, 10% is not realistic. In fact, I think instead we ought to choose something less than that, maybe 8%. Or, you know what, I think we can be more aggressive and choose 12%, whatever you want to use. Or not whatever you want to use, whatever you believe is correct, right? There's a difference between whatever you want to use and whatever's correct. Because if you walk into a briefing with this, with the CFO, and he's like, well, how'd you come up with the reinvestment rate? He's like, well, I just did what I felt like I wanted to do. You probably get thrown out. You're going to be able to defend, you've got to be able to defend what your rate is going to be. Using the corporate cost of capital is generally a pretty defensible perspective. So now we're going to try to bring 95 into the future, 100 into the future, 105 into the future, and 135 into the future. So that's going to look like this. I'm going to bring 105 into the future. I'm going to bring 100 into the future. And I'm going to bring 95 into the future. What do I have to do with the 135? I want to bring that 135 into the future. What do I need to do? It's a trick question, by the way. Leave it as it is. That's right. It's already there. It's already in the future. It doesn't need to do anything. It's already at the end of year 4, right? Everybody else needs to come up to the 135. But the 135 is already there. So what am I going to do to bring 105 up to year 4? What do I need to do? What formula am I going to use? So Mohammed's got it. Good. Yeah, you're not going to divide, because if you do 105 divided by 1.1, you're going to bring it backwards. So future value of a cash flow is the cash flow times 1 plus the interest rate raised to the number of years you're bringing it into the future, right? So if I'm going to bring 105 forward 1 year, it's going to be 105 times 1. In this case, we're going to use the reinvestment rate of 0.1, so it'll be 1 plus 0.1 or 1.1. And then I'm bringing it forward 1 year, so that's 1.1 to the 1, which is just 1.1. If I'm going to bring 100 forward, what do I do? It's 100 times good. 1.1 squared. Right. We can right? Because this becomes 100 times 1 plus 0.1, and we're bringing it forward 2 years. We're bringing it to 3, from the end of 2 to the end of 3 to the end of 4, right? So 1, 2. So that's 0.100. The future value is equal to 100 times 1 plus 0.1 squared. And then finally, for the third one, it's going to be 95 times 1 plus 0.1 to the what? Raised to the 3. Good. All right, you guys are cooking with gas now, as one of my bosses used to say. I'm not sure why cooking with gas is particularly excellent, but anyway. So now we need to calculate what each of these are. So I'm going to switch to view the, come on now, view my screen. Okay, so future value of each of these cash flows. I'm going to call that column FV. So the future value of the cash flow at year 4 is itself, right? So it's just that, because we don't do anything with that. Delete this. Don't need that now. I'm going to change that in a minute, so I'm just going to delete it so it doesn't keep doing crazy things. So yeah, if you haven't done that, or go ahead and delete the formula that we had in for the present value of the cash flows, because we're going to change that. So I'm going to bring that 104 to the future. So I'm going to say, okay, I'm going to take, this is my cash flow. So I'm going to select the cash flow times, and I'm going to program it 1 plus, and I'm going to use my corporate cost of capital as my reinvestment rate. So that's what's going to be here. So I'm going to use that. And then I've got to bring it forward, right? We already talked about this. I'm going to bring it forward 1 year, right? So I'm bringing it forward 1 year from 3 to 4, right? From 3 to 4. So in order to program this, you could do this a couple ways. You could hard code in and just say, well, I'm bringing it forward 1 year. What I'm going to say is I'm going to bring it forward 4. I'm going to lock that reference minus the year. So 4 minus 3 is 1. Oh, and I need to lock the reference to the corporate cost of capital. So I'm going to hit F4 for that too. So your formula ought to look like what I've got right now, right there. D7. So assuming you've got your spreadsheet laid out with the exact same references as I have, you're going to have D7, which is going to be the cash flow for year 3, times parentheses 1 plus the corporate cost of capital, which for in our case is going to be our reinvestment rate, raised to, and here you can manually type in 1. I think it's useful to do it this way because, first of all, I can just copy this formula now, but also it kind of keeps me from making a mistake in terms of the number of years to bring it forward. But that I'm taking the end year, which is 4, locking that reference, and then I'm subtracting the year of the cash flow from it to get the number of years. The difference would be the number of years. So if I copy this up to the next cell, we'll wind up with 4 minus 2, which is going to be 2 years, right? So, and going from the end of year 2, right, to the end of year, so from, if I'm going from cell end of year 2, I'm going to go forward 1, 2 years, right? So this formula captures that. So the future value of 104,738 carried forward 1 year would be 115,000. Now I should be able to copy this back if I did the formula correctly, which I believe I did. So 95,000 carried forward 1, 2, 3 years is worth 126,000 if it's carried forward at a 0.1. So we'll relabel this the reinvestment rate. And I'll just put CCC in parentheses. And extend that cell out, right? So to remember, we're not using the corporate cost of capital per se. What we're using is the reinvestment rate. And in this case, we happen to be using the corporate cost of capital as our reinvestment rate. So then I'm going to insert a line here. And I'm going to say future value of cash flows. And that's going to equal simply the sum of those cash flows. And now I want to make this. So now I know that the totals of each of these, and they total up to 497. So let me switch back to my screen here. So I've got roughly 115, roughly 121, roughly 126. When I add 135 plus 115 plus 121 plus 126, I get 497, 328. So that's the future value of these cash flows that have been carried into the future. They're worth 497,328. Now I want to take that, the future value of those cash flows, and remember, how did they get to be these amounts? Well, we earned 95,000, and then we reinvested it at 10%. We earned 100,000. We earned 95,000. We reinvested it at 10% for 3 years. 1, 2, 3. We earned 100,000, and we reinvested it at 10% for 1, 2 years. Then we earned 105,000, and we reinvested it at 10% for 1 year. And that's how much they were worth when we brought them into the future. Now we're going to take the total of the future values of the cash flows, and we're going to bring it back to the present. So we're going to treat this as a lump sum, right? We're going to treat this as a lump sum, and we're going to say, okay, what do I need to divide 497, 328 by? Right? What interest rate? 1 plus I, and I'm going to bring it back 1, 2, 3, 4 years, right? What I do I need to use as a discount rate to bring the 497 back to the present and have it equal 240, so that when I add the 240 to my negative 240 investment, I wind up with an NPV of 0. So that's what we're going to do next, is we're going to figure out what that I would be. Now you could do that. This is easy. You could do this on the calculator using your TVM. You just calculate the value for I. You could do it algebraically. It's a little bit of a pain, but it's not super hard to do. You just solve for I. Or we can switch back to our spreadsheet, and we can tell it now we're going to make this equal to 240,000. So we're going to say, I'm going to take this value, the future value of the cash flows, divided by 1 plus the MIRR.
Could you share your screen with us?
Am I not doing that? Sorry.
Thank you.
There it goes. All right, let me start again. I didn't realize I hadn't finished the share. Okay, so I've summed up the future values, right? 497. I'm going to now I'm going to now take this 497 and bring it back from, I'm going to discount it so that it is equal to 240,000 plus 240,000, so that when I add it to this, my NPV will go to 0. So I'm going to take this value, select this value, divided by 1 plus the MIRR number, which right now is set at our IRR of 27, but we'll just leave it there for a second, raised to In this case, it's going to be the fourth power. We'll just leave that hard-coded. So at 27%, we discount it too much, right? It goes past 240 and down to 191. So our modified internal rate of return is not 27%. It's going to be something less than 27%. So how do we get to 27 to figure out what the modified internal rate of return actually is? Well, what we're going to do is we want to set, our goal is to set NPV equal to 0. So we're going to go to data, what if analysis, goal seek, and we're going to set cell NPV equal to 0 by changing the assumptions, by changing what the discount rate is, the MIRR discount rate is that we're using here to calculate the PV. Okay, so if you've got all that, just hit OK, and Excel crunches through it, and you wind up with approximately 20%. We can get a little bit more granularity, and it's actually 19.98%. All right, so all the assumptions that we worked through just now. Sorry?
Can you do that one more time with the goal seek? Like what you set the numbers to?
Yep. Let me reset this to, 29% or whatever it was. Okay, so what we are shooting to do is get this so that it's equal to 240,000. So then we add this and this together, we get an NPV of 0. Okay, just like we did with the IRR. We're looking for that interest rate that sets the future value of our cash flows equal to exactly equal to the investment. Okay, so what we want is to tell Excel. So we're going to go to data, go to the what if analysis, and then we're going to choose goal seek. A little window pops up here, and we're going to tell it the first line, the first entry is set cell. So right now it's set on E13, which is the NPV. And that's actually what I want it to do. So I want it, but if I wanted it to be here, I would just choose a different number, but I don't. I want it to be NPV. I want to get my NPV to 0, right? Because what I want is for when I modify that number, right? When I change the MIRR, the number of the percent I've entered for MIRR, I want it to be just the right number so that it discounts my future value to 240,000. So that when I add 240 to minus 240, I get 0. So I've set cell 0. So I'm telling Excel, I want to get that NPV to 0. So in order for you to get that NPV to 0, you're going to have to modify this number, right, so that it's equal to this number, right? So Excel knows that because that's all programmed in. If you can see it, right? These two added together have to equal 0. So Excel says, okay, what do I have to change in order to make that thing go to 240? And it says, oh, I go up here and change this number. So I'm going to say, okay, I want you to change this number. I want you to change the 29% to some other number that is going to cause the PV of the cash flows to go to 240. So once I have that, I just hit OK. And Excel goes to work testing all the different numbers. It's got a little algorithm it does, right? And it gets us to 19.98. And I can close that. And I have an NPV of 0. And that tells me that my modified internal rate of return is actually, roughly 20%, 19.98. All right. Did anybody else not able to follow that this time? You can privately chat me if you want me to run it again. I'm not seeing a message. Okay, so I'm not seeing, it seems like everybody's got it. Okay. So we've been able to model right? We built this nice model with all the assumptions kind of running in the background, so that it's nice and neat. And part of the reason I want to do that is I can do things like, if I've got all the relationships programmed, I can use functions like goal-seek to do the heavy lifting for me. Now, again, all that work said, right? You don't actually have to do all this if you don't feel like it. You can just type in equals MIRR, and then Excel tells you, okay, yep, we got a formula for that, right? And so you tell it the value. So just like IRR, but unlike NPV, you include the investment as well as all the cash flows. And then the finance rate is the corporate cost of capital. And then the reinvestment rate is, in our case, also the corporate cost of capital, though it doesn't have to be, right? So for us, it's going to wind up being D4 to D8, which is the initial investment plus the 4 cash flows, the finance rate, which is the corporate cost of capital, and then whatever your reinvestment rate is. And in our case, that's the same thing as the corporate cost of capital. Close the parentheses, hit return, get 20%. But as you can see, so the shortcut is MIR is you just need to know the MIR formula, or you need to know that there is an MIR formula, and then you need to set up your cash flows correctly. But I would like you to be able to do it either way. On the exam, I'm not going to force you to do it one way or the other, but you may find it useful to be able to do it the way that I laid it out. So, kind of one more time, the key difference between IRR and MIRR is IRR assumes that you'll be able to reinvest each of your cash flows at the same rate as the overall project. That's probably not a realistic expectation. MIRR, the modified internal rate of return, separates the reinvestment rate from the project rate. And the reinvestment rate is, you get to identify what you think it should be. So in this case now, so with modified internal rate of return, we said, okay, we got 95, we brought that into the future. We got 100, brought that into the future. 105, brought that into the future. And we brought them all into the future at some reinvestment rate, which for our purposes we're assuming is the corporate cost of capital. Now we don't have to. We don't have to assume that, and it's not necessarily always the case. But it's a convenient kind of a rule of thumb, right? That, other things being equal, that would be a reasonable assumption. Okay, and so one of the things that's true about this is you notice that our MIRR is lower than our IRR, right? So our MIRR is 19.98%, our IRR was 27%. So if you have a project with a positive NPV, your IRR is going to almost always be larger than your MIRR. In a sense, especially if you use the corporate cost of capital as your discount, or as your, sorry, not as your discount rate, but as your reinvestment rate. And the opposite is also true. If you have a negative NPV, your IRR will be more negative than your MIRR. So it's kind of the MIRR kind of squishes the range of returns, percent returns, right? The IRR is a little more extreme. So in this case, we had our IRR was 27 and our MIRR was 20, still really good. right? But 20 is a lot less than 27. And had we had, say, like a negative 20 IRR, our MIRR would have been, say, I don't know off the top of my head what it'd be, but something less than that would be, say, negative 15 or something like that. I'd have to calculate. There isn't some simple rule that I could just use in my, off the top of my head to estimate that. Okay, so we have 3 tools now that we can use to calculate profitability, right? We have the MIRR that we just did, IRR, right, so MIRR requires an extra step. You bring your cash flows into the future, then you take the total of the future value, you treat that as a lump sum, bring it back to the present so that it's equal to the investment, initial investment, whatever rate it is that you need to bring the future value back to the present, that becomes your MIRR. Your IRR, right, simply says, I'm going to use one rate that I'm going to apply to all of my cash flows and bringing them all back to the present. Now you're going to use different exponents, right, because the exponents are tied to the number of years, but the I that you use in the present value formula is going to be the IRR. And your goal, again, is to discount all of your cash flows so that when you sum up the present value of the cash flows, discounted back at the IRR rate, when you sum all them up, they're equal to, the sum of them is going to be equal to the initial investment. And then finally, our good friend, the NPV, which is actually my preference. You calculate, you use the corporate cost of capital to discount the future cash flows back to the present. You sum them up and you compare them to the initial investment, and the difference tells you, if it's positive, tells you it's a good investment or not. Right? Both with the IRR and MIRR, you're going to say you use the same standard, which is the MIRR or IRR greater than, equal to, or greater than the corporate cost of capital? Okay, so if the corporate cost of capital is 10% and your IRR is 20%, 27%, that's a go, right? If your MIRR is 20% and your corporate cost of capital is 10%, that's a go. You're always going to get the same answer with all of them, right? Well, that's not true. With MIRR, you could potentially get a different answer than with IRR, but you should get the same answer. IRR and NPV, you're always going to get the same answer. MIRR could be you could wind up with a different answer than the other two because of the assumption around the reinvestment rate. So if you had a low enough reinvestment rate, it's possible you could wind up with a different answer. Okay. So 3 methods. So how are we doing on that? Any questions on what we did there? Do we want to do any of that again?
I just have a question, Professor Monica.
Yes, ma'am.
So you were saying that the reinvestment rate isn't always the same as the corporate cost of capital.
Right.
So like on an exam, you would tell us if they were different?
I would have to tell you, yes.
Okay.
Yeah, so, and you can see the impact. So looking here, right, you can see so right now it's a 10% reinvestment rate. What if we had a 12% reinvestment rate? It impacts, right? And so we'd have to recalculate. It's actually going to go up to 20.79%, right? Because if we could reinvest at a higher rate, then our overall project winds up coming in at a higher rate. What was our IRR? 27%. So if I put in 27% here, right, we wind up with very close to 27%. I bet this is, yeah, 26.92. and 26.96. So we're very, very close. You know, there's a rounding error off between these, right? Probably because, well, because I didn't put 26.92 in here. So if I put 0.2692 in here, I wind up with 26.92. So to your question, Elizabeth, yes, I'm going to have to tell you what that is. So I will tell you something like the firm, you know, calculate the MIRR. Assume that that any cash flows the firm receives will be reinvested at the corporate cost of capital, or assume any cash flows the firm receives are going to be reinvested at some other rate. But I will have to tell you what that is. Yeah, you're not going to just make it up. I mean, I would default to the corporate cost of capital if I didn't have another rate. But for exam purposes, if you don't see a reinvestment rate, either you're not reading the problem carefully enough, or I made a mistake, one or the other. In the real world, you'd have to decide, you know, as a real world analyst, you'd have to think about what an appropriate rate would be. But for exam purposes, it'll be given to you in some way.
Okay, thank you.
Yeah. All right. So let's go back. I was playing earlier with the sheet. So let's go back here and look at a couple of things. So now we're back on our original sheet, and let's assume now that we have a for-profit company. So that means that they're going to pay taxes. Now, as a result of the tax, I forget what the Tax Act was actually called, but corporate tax rates have been reduced to 21%. So let's change our assumption from zero taxes with a not-for-profit to a for-profit with 21% tax rate. So you can see now, because we designed our original spreadsheet with a row for taxes, it's tied to the taxes, it's the tax rate times the operating income. So the operating income here is 35, so 0.21 times 35 gets us 73.50, and that 0.21 is going to flow all the way through here. So if you followed me when we built this, it should just kind of slide along for you. So now we've got a slightly different outcome for a for-profit. They're paying out some taxes. One thing we've got to still do, though, is our salvage is happening outside of our taxes. So one thing we could have done was maybe put the, you know, salvage value in as part of the operating income. That would be an option. So like we could take this whole row and move it up here. I'm not going to do that right now. But since we didn't do that, and we're assuming that our asset, so our asset cost us $240,000, right? And we have depreciated the asset each year at $60,000 at $60,000 a year. Our book value of our asset now is zero. So let's just do a little. Let's do a little estimate. Down here we'll write book value, and this will correspond with our years. So at year zero, at time zero, the book value of our asset is going to be $240,000. So I'm going to type equals. I'm going to put in a negative sign, and then I'm going to grab the original purchase price of negative $240,000. Right. So all I did was I said equals negative E3, 240. And now what I'm going to do is I'm going to get the book value. So the book value is the value that we would report to the IRS about our about the asset that we own. So this scanner or whatever we said it was. And maybe we ought to say this is our tax book value. So let's call that our tax book value because I'm going to tweak it in a minute. And so our book value for tax purposes is going to be 240 going to equal the purchase price minus the amount of depreciation that we take. And it doesn't really matter where we take it from. Grab it right there. So what did I do? I subtracted 60,000, the depreciation rate, from the taxable book value of 240. So the value of our asset at the end of year one went from 240 to 180. In year two now, I should be able to just copy that over. It should go to 120. Then in year three, it's going to go down. So what we're doing is we're subtracting from the original purchase price. Each year we're getting some depreciation, right? And we're lowering the book value of the asset, so that when we go to sell it at the end of year four, it has no book value. So why is this important? Well, oh, camera. Sorry, jumping ahead of stuff. If our firm, let's say at the end of year two, our firm changed its mind. So we had an original book value of 240, right? This is our purchase price. And then at the end of year two, our accumulated depreciation would have been 2 years worth of depreciation. That'd be 120,000, right? Add that together and we have a net PPE, right, or net book value of 120. So if we were to, yes, ma'am. Sorry, I didn't hear what you were saying.
Could you focus
Can
the
you
camera?
focus the camera?
Oh, yep. Is that good? It's hard for me to see. That looks in focus to me. Is it okay?
It's good now for me.
Okay, good.
Yeah.
Sorry, I moved the camera. I should have made it focus again. All right, so the net PP, the book value that the firm is going to sell this at, well, the book value matters because if the firm sells the equipment, let's say sale price, let's say the firm sells the equipment for 150. The book value or net PPE value is 120. So the firm then makes a profit from the IRS's perspective of $30,000. Okay. So if the firm bought the thing at 240, it's taken $120,000 in depreciation. It's now reporting to the IRS, our equipment is worth $120,000, and then we turn around and we're able to get somebody to buy it from us for 150. The book value being 120, the IRS says, "Hey, you said that your thing was worth 120. We gave you tax breaks based on your taking $60,000 in depreciation each year. We gave you tax breaks for 120,000. So that equipment, from our perspective, is worth 120. You sold it for 150. So you now have to report $30,000 in profit, or income that you are now we're now going to tax you on." So they would then pay taxes, right, of 0.21 times 30 1,000, which is 0.21 times 30, 6,300, right? So they would get $30,000. They would net 30,000. They would pay 6,300 in taxes. So their net would be 23,700. That would be their profit that they actually get, because they had to pay. That's a mess. They have to pay Uncle Sam 6,300, or 21% of that profit. Now this is called a capital gain, right? When you sell something that you've held for a while, so they would report a capital gain of 30,000. Right. So let's switch back here for a second. Okay, so if our firm now fully depreciates the asset such that the book value is 0, right, at the end of year 4, at the end of year 4, right, the book value is 0. So at the end of year 4, they're going to sell that equipment for $25,000. So just like a second ago, we said, well, if you sell it for 150 and the book value is 120, then you have income of 30,000. In this case, if the sale price is 25,000 and the book value is 0, right, then the capital gain is going to be 25K. So they're going to have to be taxed on that 25,000. So that's the point I was trying to make here. It's a long way to getting to it, right? Is we're not done. We've got to do something else with this 25,000. We've got to allow for the taxes. So what we're going to do is we're going to subtract off the taxes. So we'll take 21% times the salvage value, which we've got over here, right? So we've got the salvage value, B10, right, 25,000, minus 21% of 25,000, which is the taxes that the government is going to require from our little firm. So that's going to be 25,000 times 0.21 is 5250. Right? So 25,000 minus 5250 gives us 19,750. So that's kind of the last step for closing out if this was a for-profit entity. And then we could see, okay, how's the NPV doing? Well, the NPV is a lot lower. It was 100, I think it was 103,000. So we don't have to do anything to recalculate the NPV because that's done for us. The IRR, well, Excel automatically modifies the IRR. We would have to redo our, redo our goal seek. We could do that real quick. Data, what if analysis, goal seek. I'm going to set the NPV equal to 0 by modifying our estimate of our IRR, right? And we get 21.92%. So they match up. And then our MIRR, we'll go back to assuming 10%, has fallen as well, right? And again, we go to data, goal seek, set that equal to 0 by changing the MIRR estimate, and we get 17.11. So one of the advantages of using the Excel formulas as opposed to doing this goal seek process is Excel will automatically update it as you change the MIRR and IRR as you change the underlying data. Whereas if you do the kind of more manual process, you're going to have to go in and redo it. All right, we've got like 5 minutes left, and I want to show you something that I'm not going to test you on, but you should be aware of. So I sent you a file or rather I posted a PowerPoint file that looks like this in the chapter 14 notes. And this is called MACRS, Modified Accelerated, I don't remember. It's the depreciation that businesses use for taxes, for tax purposes, okay? And so there is no 4-year depreciation schedule from the IRS perspective. There's 3, 5, 7, 10, 15, 20, and there's some other longer ones. So our business would be using MACRS for tax purposes if it was a real business. So this file is on Canvas. I'm going to quickly tweak our assumptions here. So in year one, what MACRS does is it allows businesses to take more. It allows businesses to take larger chunks of the depreciation up front. So in the first 2 years, you get to depreciate half of the value of the asset. So with a 5-year straight line depreciation, you would have taken 40% after the first 2 years. Under MACRS, you take 52% of the first of the value in depreciation. So why is that useful? Well, it reduces your taxable income, right? So if this is instead of straight line, is instead 0.2, I'm going to hand jam it in here just for sake of time, times this, I want to make it negative, right? I take 48,000 in the first year. I take 32%, so negative 0.32 times the equipment value in the second year, right? And then in the third year, I take 0.192. I need to make that negative times the purchase value, and then in the fourth year, I take 11.52 times 240. What did I do there? Oh, I made it 11.5 instead of 0.115. All right. Now, that said, so then we have, we still have book value of 41,000 because MACRS, because first of all, we wouldn't be allowed to depreciate, this equipment would not be a 5-year equipment, it would be a 4-year equipment, it would either be a 3 or a 5-year equipment. So we've still technically got 1 more full year of depreciation. What MACRS does is for and I'm not gonna get into this because I've got 1 minute left. MACRS actually, it allows you to accelerate up front, but it kind of drags out the last year an extra year. So you get this like little tail of depreciation at the end for an extra year. But the key point here is if this was 5-year equipment instead of 4-year equipment, the book value would still be 41,000. So if we were to sell it for 25,000, we would actually have a loss, which would be an increase to us. So our tax loss would be this minus 25,000, gives us 16,000. So we would get our 25,000 plus we would have a tax loss of our tax rate 0.21 times our capital gain loss of 16. So it would actually wind up being a plus for us. We would, actually wind up having, on the salvage value, we would wind up getting a little extra kicker back. Okay, you're gonna have some problems dealing with Mackers in the chapter 14 homework. So I just wanted to show it to you. They will give you the rates to use in the homework. For the test, we will do straight line depreciation just because Mackers is confusing and I'm not gonna deal with that. Okay, so that is the rest of chapter 14. The homework should be due next time, but since next time is our econ exam, we'll make the homework due Monday. And I think actually I just glanced for some reason, the homework due date in the homework due date is like April 27th or something. So that's obviously not correct. So I will change that in a moment after we hang up. But let's plan to have the homework due on Monday, so that way you can focus on the econ exam and then do the finance homework as part of your kind of studying for the finance exam, which is next Wednesday. All right, I will see you guys. I'll hang out. I will see you guys. So if you want to have a question for me, I will hang out. Otherwise, I will see you at 3:40.